Good morning all. Today we are going to see the topic temperature sensor. The temperature sensor is the application of optical fiber. Here it is based on the principle of interference. When the beams coming out from the reference fiber and test fiber, it produces the interference pattern. From the interference pattern we can measure the temperature of the any environment. It consists of laser, then beam splitter, then there are two fibers. One is for reference and the other is test fiber, which is placed in the measuring environment. It consists of laser, beam splitter, then reference fiber. There are two fibers. One is for reference, another is for test fiber, which is placed in the measuring environment. When the laser is allowed to fall on the beam splitter, then the splitter split the beam into two. One is allowed to this reference fiber and the other one is allowed to the test fiber. Here, the light characters will be affected. So, the output of the reference beam and the test beam create the interference pattern. From this interference pattern, we can measure the temperature of any environment. Hi students, good morning all. Today we are going to discuss about the topic temperature sensor. It is based on the principle of interference between the emerging out the beam from the reference fiber and the test fiber. That means the fiber is kept in the measuring environment. It is the basic principle. The basic concept is interference. From this interference pattern, we can measure the temperature of any environment. Its description, it consists of monochromatic source. Here, we are taking the helium laser, then the beam splitter. The beam splitter split the source into two. Here, we are using two fibers. One is reference fiber, another is test fiber. That is, the fiber is kept in the measuring environment. Then, the output of the beam is given to this detector. Okay, this is the description. Now we are going to explain the working. When the laser beam is allowed to fall on this beam splitter, then what happens? The beam split into two. One beam is allowed to this reference fiber. This is for only reference purpose. Then the beam is allowed to the test fiber. Here the beam is suffered by the temperature and pressure. So the output of the temperature fiber and the reference fiber produce, there is a path difference between these two beams and it produces interference pattern because of the different temperature and pressure. Okay. From this interference pattern we can measure the temperature. Okay. It is one of the applications of optical fiber. One more application is displacement fiber. In this displacement fiber, we can measure the distance by analyzing the intensity. If the increasing the intensity, the object is moved towards the detector. If the intensity is reduced, the object is moved away from the detector. Okay. There are two applications. One is temperature sensor, another is displacement sensor. Okay. In the next class, we will see the. Hi students. Good morning all. Today we are going to see the topic temperature sensor. Before that, we are going to discuss about optical fiber. What is meant by optical fiber? Nowadays we are using optical fiber for communication purpose instead of copper. Why? Because its loss is minimized. That's why we are using optical fiber. It carries more information That's why we are using optical fiber. You know the basic principle of optical fiber. It is total internal reflection. Before that, we are going to see the structure of optical fiber. In this structure, there are three types of layer. One is core, which is inside the optical fiber. The inner layer cylinder is called core. It is surrounded by cladding. These are covered by polyurethane jacket. It's a protective layer. Already you know that. Already you studied in school days. The basic principle is total internal reflection. The condition for total internal reflection is N1 is greater than N2. What is N1? The refractive index of core. What is N2? The refractive index of cladding. Here, the N1 is greater than N2. Then only you can get total internal reflection. That is the basic principle of optical fiber. Okay. What is meant by refractive index? Do anyone know that? Is the velocity of light in? Welcome to velocity of light in medium. U equal to C by V. N1 is the refractive index of core and N2 is the refractive index of cladding. Okay. Now we are going to discuss about temperature sensor. It is one of the applications of optical fiber. There are two applications. One more application is displacement fiber. Displacement sensor. Okay. What is the basic principle of temperature sensor? It is based on the interference between the emerging beam from this reference fiber and the test fiber. Okay. Is the basic principle of optical. The basic principle is interference. Okay. Now we are going to see the description. It consists of monochromatic source, that is laser. Also it consists of beam splitter. It split the source into two. Here there are two fibers. One is reference fiber. Other one is the fiber is kept in the measuring environment, that is test fiber. Now we are seeing this. Okay. When the monochromatic source is allowed to fall on the beam splitter, then what happened? The beam splitter split the source into two. One is given to this reference fiber, other is allowed to this test fiber. Okay. Here, already we know that due to the temperature, it affects the property of the light, temperature and pressure. So the emerging beams from this reference fiber and test fiber produce the path difference. From this path difference, it produces the interference pattern. From this interference pattern, you can measure the temperature of any environment. Like your average experiment. I think you done an experiment in your laboratory, physics laboratory, average experiment. By using the fringes, you can measure the thickness of the paper. The same concept is here. The path difference is produced between the test fiber and reference fiber. From this path difference, it produces the interference pattern. From this interference pattern is nothing but the fringes. From this interference pattern, we can measure the temperature of any environment. Thank you.